So for this question, we are going to find the domain for each of these three functions. I would say the domain of a function is the collection of all the x values that if you put into the function, each of them could generate a y. So let's look at part A. In order to find the domain of this log function, the best way is to remember how exactly does a log function look like. Well, generally, the log function looks like this, right? So in this case, only all the x greater than 0 will they produce a value for y. Okay, when x equals to 0 or less than 0, it's NA, right? So in other words, what goes into this bracket? Usually it was just x, right? This thing must be greater than 0. And so we could say this function, this y, is real only when this thing inside is greater than 0. And so the domain must be x greater than 2. Now for part B, because it's a square root, this thing inside must be greater than or equal to 0, right? And so in other words, y is real only when this thing inside is greater than or equal to 0, and so x must be greater than or equal to -5. And so the domain is x greater than or equal to -5. Now for part C, it consists of two parts. This is from part A and this is from part B. And this whole thing is real only when they both are real. And so when I put these two together, the domain would be x greater than 2. Now after domain, let's talk about period. So period basically means how long in terms of the independent variable, the x. How long will it take to repeat one cycle? Sine graph. You have to remember how it looks like in the beginning for a general graph. This is a sine graph. Of course, you have to remember all three graphs. Okay, so let's start with the sine. Generally for a sine, okay, this is one cycle, right? Whenever you go further down the road or before that, this cycle, this pattern is just going to repeat itself. And so the period it takes is just 360 degrees for this, okay? 360 degrees to repeat one cycle for sine. Now this one, what happened to this? Sine x becomes x minus 80. What this is doing is just shifting the whole thing to the right because it takes an extra 80 degrees to get to where we do. This is just like that. Okay? And it has nothing to do with the period because it's just shifted to the right. So for part A, your period is still 360 degrees. It does not change. You may ask, what about a cosine? Cosine graph basically is just a sine x shifted more. So the period is still the same for cosine, same as sine x. Now tangent is a little bit more complicated, okay? But you still have to remember, this is one cycle, but if you still remember the position, this part would be 90 and this is 270, and this falls right in the middle. And so the period would be just 270 minus 90, and it's 180 degrees. And you have to begin by remembering these three things. So part B, what happened? Here's some tips for you. This number that multiplied by your x, this is saying how many times the x is running faster than original. When you're running 3 times faster, that also means you take less time to complete a cycle, right? And so in this case, your period is 3 times shorter. And finally, this 4 outside doesn't change our period because what it means is that whatever I've calculated after the tangent, I will multiply it by 4, which means whatever number you've got here will just go up by 4 times. Okay, so that doesn't affect the period. And so your period would just be the original 180 divided by 3, which is 60. Now because we are given with the degrees already, so I should probably take out these 2 degrees here.